y prime equals negative 2y. So to begin, we're going to want to use an integrating factor. This is the formula for the integrating factor. So we're going to have mu, which is our integrating factor. You may call it something differently. It's going to be equal to e to the negative at. Capital A of t is the integral of little a of t. And in this case, little a of t is negative 2. So the integral of negative 2 is negative 2t, and then we want to have the negative of that, so it's going to be positive 2t. After that, we're going to go ahead and multiply the differential equation right here by this integrating factor. So we're going to end up with e to the 2t times y prime plus 2y. I'm just going to move that 2y to the left side. And then we're going to end up with 0 on the right side because e to the 2t times 0 is just 0. If I number these steps really quick, step 1 is to find the integrating factor. Step 2 is to multiply the differential equation by the integrating factor. And then in step 3, we're going to go ahead and find the complete derivative. So the complete derivative would be, and I'll explain how I got this in a second, y e to 2t prime. Okay, so we basically wrote the left-hand side as a complete derivative, right? The entire side is a derivative. And this right side will end up being 0 again, because 0 and 0 prime. So this statement here is equivalent to this statement. The derivative of y e to 2t is equal to this. You're going to use a product rule, and you're going to end up with y prime e to 2t plus 2y times e to 2t, and then you're just going to end up factoring out the e to 2t. So this is kind of like the anti or opposite product rule. It's not the antiderivative essentially, because you can't really use the opposite rule, right? So a good trick would be to say the integrating factor times the function, and then just go ahead and take its derivative, and that will typically work most of the time. Alright, so the reason why we find the complete derivative is because if we take its integral like this, then this integral and this derivative will cancel, and we will end up with a nice solution essentially. The right hand side, the integral of 0 is going to be 0 plus c, so I was going to add a c there, and then we're going to divide both sides by e to the 2t to find its implicit solution. So this is going to be our answer. This is going to be our solution to the differential equation y prime equals negative 2y. If you're given an IVP or initial value problem, you can utilize that right here and then plug it into c right here. And if you're asked to find a potential function, then just solve for c, and that will be your potential function.